Now this is often has a delay, particularly on a cold day, so it's not too bad today, hopefully. Sometimes the delay can be such that it happens in my car going home, up the A1, your boot's on fire, sir. I'm really sorry, officer. What else have you got in your boot? Oh, all of these chemicals that go banging on fire, where have you been? In a school, officer. Have you now? You see that van? Get in. You know, I thought you only ever thought about football. Well, you see, I'm a romantic. Oh, people will say, her hanky smells gorgeous. We need to get the perfume off my fingers before the next bit, so that we don't have the smell of fingers, but anyway. Here is some glittery powder. You sprinkle that on your hanky, people will say, what a flashy hanky she's got. Oh! She steps back in surprise. Or, had she been blowing her nose at the time, she steps back in shock. Because the iron will be oxidized up to iodine, which is brown. At least that's the plan. But we'll have to see how it works, because it's not always a reliable experiment. And, oh no! No, not that much! The floor! I've been warned about the floor! Burn me now. Oh, it's all right, laughing now. Oh, yes. Oh, the poor man. Oh, the table. I promised about the table. Don't let on. We'll try and pretend it's not happening. But don't let on. Don't let any staff here know. Oh, dear me. Well, I wish I brought my razor now. Have a nice shave while I'm talking to you. Stop, man, stop. Stop. Come see it. Quite nice, that, isn't it? I thought it was nice anyway. But, you see, I then began to think, well, the year 8s, year 9s, are they going to be turned on by a big test tube? Really? Not likely, are you? It's not, you know, if I say, have a look at this, you'll be probably talking to your mate, won't you, rather than that. So what can I do to make this more exciting for you? Then it came to me in a flash. I can pack it full of high explosives and set fire to it. Now, how about that, eh? That's a better idea, isn't it? So there's already in this test tube one of the ingredients. It's called nitric oxide. It's a gas. It's colourless, and its chemical formula is very, very easy. It's a capital N for nitrogen and a capital O for oxygen, and it's those two connected together. So its formula is NO. You'll never forget that, will you?
No.
No, correct. Okay, now, the other chemical that has to go in, unfortunately, is this one, which is called carbon disulfide. And carbon disulfide is a volatile liquid whose odour, whose vapour has a characteristic odour. Have you got that? A volatile liquid whose vapour has a characteristic odour is a nice way of saying this stinks. And it stinks of rotten cabbage on a bad Monday morning. Now, unfortunately, when I always got to get it from there into there, so I have no choice but to get a whiff of this. And you at the front may well get a whiff of it. I doubt in this high hall if it'll go much further back. So you're the lucky ones, and we'll know you because this is what you will do. And that will be in a futile attempt to not sniff it, because that doesn't work. Anyway, in the meantime, I am now going to put some in here. Okay? Let's have a look at this. See if we can find out where I left the tab. Must have left it somewhere. Not there, there. Now, when I open this to put the carbon disulfide in, the gas at the top, the nitric oxide at the top, will react with oxygen in the air, and it will produce another oxide of nitrogen called nitrogen dioxide. Di means two, which formula is NO2. And NO2 is a brown coloured gas with a pungent odour. Smells a bit like a swimming pool. So there's a measuring cylinder. Now you just have to excuse me because I'm taking this top off. I may be sick. Oh, it's foul. Come on. Oh, it's gone on my fingers. No. Oh, help me. Oh, it's lousy. Excuse me, I'm sorry. Okay, now watch for the brown fuse now, okay? Did you see any? Good. Oh. The snag now is, if I set fire to this with nitrogen dioxide in the tube, the level of the explosion will be enough to put me and probably these two tables all in A&E. We don't want that to happen, so I can't do with nitrogen dioxide remaining in the tube, you see. So what I have to do is make use of the chemistry here, because nitrogen dioxide dissolves in water to make nitric acid. Nitric oxide does not dissolve in water. So if we switch this water up and down, and if ever you were doing a talk like this when you're science teachers, always leave water in the bottom. Don't do what some do, because then you will properly hurt yourself. Right now, that water should have dissolved out the NO2, and we should just have the NO in here. Now here is a lovely wax taper look, pristine, because coming into Darlington, I happened upon a church that wasn't locked. No? All right. It's only a joke, it's only a joke. We don't rob churches. Get my tapers from my ecclesiastical suppliers. Churches. Right, now. Are you ready? Just give me a minute now. You ready? My nerves. Right down my shirt from, that was nice. Hey, that cooled me down now. Oh, dear me, see, I'm not burnt or hurt or damaged, am I? And I can tell you I have been doing that for more than 30 years. My hairstyle has never altered. No long-term effect. Belong to the Society for the Prevention of Cruelty to Bananas. Stand aside now and we plunge the banana mercilessly into the liquid nitrogen. The banana is cooling. The nitrogen is boiling uncontrollably because an object which is more than 200 degrees above its boiling point has been immersed. It's like putting red hot metal in a bucket of water. My finger and thumb are also cooling, unfortunately. Now, You know what? The pursuit of science is a wonderful and a noble thing to do, and mankind cannot help but do it, because we've all been born into a universe that is absolutely fantastic and amazing, and we cannot help but try and work out how it all works, what its laws are, why the sky is blue and not another colour, why grass is green and not another colour, why the moon comes round as often as it does and not any other age. All of these are questions of science, and the pursuit of science can never be wrong. It's a beautiful thing to do. But you know, when we get new discoveries, and I was telling you about Nobel, most new discoveries can be used to do really good and kind things and make people's lives a lot easier and better, or they can be used to do wicked things and make people's lives miserable. Who decides on that? Not scientists. The whole of humanity has to make those decisions. The pursuit of the knowledge itself, the science itself, that can never be wrong. And so here we are, we're pursuing a technology here. It's going to emerge from this liquid nitrogen. And you have been so unfortunate that your fence has blown down in the gales. You need to hammer that nail in. And you know what? You've lost your hammer. Boring people look for hammer. Rich people go and buy a new hammer. Exciting technological people go to greengrocers, buy bananas, go to liquid nitrogen shop, buy liquid nitrogen, freeze the banana in the manner shown, and then use the banana to hammer in the nail. Ha 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 ha. Oh, we'll all laugh at a poor man whose banana snapped. Oh, we're not short of laughing at that. Eh? We might not laugh at his joke, but we'll laugh at his misfortune. Eh? Ha 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 ha. Well, I've got the best laugh because I've nailed this piece of wood to the school's best day. You decide. Hydrogen probably, but always repeat your experiments.